Hello, my name is James LaFarlette, and I'll be talking about Ticket Bleed today. So, what is Ticket Bleed? It's very similar to Heartbleed, as you might have guessed from the name, except for the amount of information that you can get from it is much less. You can see 31 bytes instead of around 64 kilobytes. That was the kind of leakage comparison you're getting there, and the affected servers or services are much smaller. It affected far fewer than Heartbleed did, and much smaller names as well. But you can see there, it affected the TLS and SSL stack of F5 Big IP appliances. I'm about to explain what F5 Big IP appliances are if you don't already know. So F5 Big IP appliances offer application delivery controller services, essentially. That is a server or software that runs on a server, that's offering cloud computing. They also offer virtual versions of this so that you can have virtual application delivery controller services. But what do these do? They are load balancers. What that means is servers are going to be able to, as it says there, see the traffic, inspect it, control it, essentially. So if you get repeated attacks from a specific IP address or whatnot, you can actually cut that off. It really helps in preventing DDoS attacks, distributed denial of service attacks, where you overflow a server and cause it to essentially shut down. So a very, very interesting topic. I'm only going to brush the surface here on F5 Big IP services, but if you're interested, definitely look them up. So I mentioned before TLS. That's the security, the updated security that's being used here, the protocol. It's a transport layer security, as you can see there, and really there are 7 layers there, and I'm about to explain those 7 layers, but I just had a little tidbit there at the bottom that TLS was used for adding the HTTPS secure protocol there to Netscape's Navigator web browser. The significance of that is Netscape was the original designer, if you will, of SSL, which was the predecessor to TLS. So here's kind of the breakdown of layers 4 through 7. 1 through 3 is really the physical setup there, with the link to the router and the network there that it's within. But 4 through 7 is actually communication outside of like a local network. I'll just give you a second to look through that. You can see the TCP, UDP kind of connections there, session layers. It's all a little bit above my head. I don't know if other people might have more knowledge than me. I'm sure that other people in this class have more knowledge than I do, but you can really dig deeper on all of these things. But if you want to get more information about this, feel free to pause it right here, read through those. I'm going to continue on. This is kind of an example of like a handshake for initiating that communication between the host and the client, or the client and the server here. But instead of it being having several, because most of the time it would be 4 or 5, maybe 6 messages back and forth. Here you just have the 4. And really, after that initial client message, the server is able to send a finished message, which means that the session ID and ticket was accepted by the server. And after that finished ticket is sent and the server hello is sent, the client can verify that, that they can authenticate and all that stuff. There's a lot more that goes into it than what I'm explaining here, but essentially, this is just a visual example of what might happen with a TLS request. So SSL, the predecessor to TLS, I only bring it up because they are sometimes used interchangeably. It's a security technology for establishing links between servers and browsers, host and clients, however you want to think of it. And the main thing is it's ensuring privacy and integrity. Essentially, two of the main things we look for in security. So, who discovered TicketBleed? I got this from doing a Google search, first of all, for TicketBleed. So it gives you kind of a breakdown of the timeline, exactly as it says there. But the main discoverer of TicketBleed was this Cloudflare crypto team collaborator, Filippo Valsorda. And he actually walks through step-by-step kind of with kind of an abridged version of what happens on his website or on his blog, filippo.io. But that timeline there shows you just how quick, really, they were able to resolve this issue working with F5. And again, Cloudflare, I don't know if I explained it earlier, but Cloudflare offers services for cloud computing, security in cloud computing, as well as kind of increasing the speed or decreasing the latency, however you want to think of it, with cloud computing. So let's jump into that explanation by Filippo about this issue, TicketBleed. So here we have a PCAP, packet capture, from Railgun, which is this Cloudflare program that's used to speed up communications between the server, data centers, and the client. Essentially, the client's using this this F5 load balancer, which I talked about earlier. But you can see here that that they've got this capture, and he talks about that things look normal, and then the server, the client's establishing communication. The server also, establishes communication, but immediately they have that change cipher spec that was kind of their flag. They go into that and they say, this is obviously what the issue is, because they got several like red lines there that are kind of just like flags that are popping up because of this issue. And you can see the alert there on that line 8 or number 8, level fatal description unexpected message. So, this is the system saying something's not right. So in here he talks about how the program Railgun is written in Go, which is a programming language. I'm sure everyone knows that, but anyway, so he's saying that in order to use session tickets, you have to enable it manually on the client side, which means that someone who would be exploiting this would have, pretty good knowledge about how to do it. You couldn't just accidentally do this. Something that you would, definitely know you're doing. So if it was to be attacked, it would have been a targeted attack. So he runs this little test, and he gets an error message. And so to dig deeper, he tries to find the error message, and he finds it here at the handshake. So and it shows you here, the server is thinking this is a resumption, meaning that there was a server, a session ticket or a session ID provided and recognized by the server, but the actual session ticket or ID that it sends back must have been different, because the client tries to go on and do a full handshake instead of saying that what it got back was what it sent. So And you can see here, yeah, the F5 server, he says it's padding the session ID to its maximum length of 32 bytes, whereas Go uses 16 bytes for the session ID. It's really important to note here that in this line, it is all zeros there, so it does look just like padding. And it's an obvious reason for the failure. You saw it in the code. It was looking for the exact same thing back, but it didn't get the exact same thing back. But in the next one, he talks about he was going to just write it off, and then he ran a few more, and he said, wait, that's not padding, that's uninitialized memory. So, there's obviously a vulnerability there. So he got in contact with F5 pretty much immediately, and they were trying to shut it down, trying to lock that ability to use session IDs down so that it would prevent this problem from continuing. So what did this really mean? How does this affect people? Well, most people went on completely unaware that there was any kind of issue. I don't know the exact number of websites that support session tickets using this F5 big IP, but you can see that 0.4% of those websites were found to be vulnerable. That's not a lot. And when it was initially found, like I said before, they locked it down. Cloudflare and F5. So that's pretty much the end. I just want to go through some of my sources, and you can decide whether or not I'm, using credible sources or not. But I used Wikipedia when I was first starting off after I saw, this ticket bleed to figure out what is TLS, what is SSL, what is PCAP. It's not like I hadn't heard these terms before. I just wanted some clarity. When I saw F5, I looked up F5 because I'd never heard of them before. Filippo.io is where most of this information was found. Cloudflare, the company that he works for, actually, he had a link posted to Cloudflare with an explanation about TLS 1.3 that was very helpful. And if you go to Filippo.io and you read this blog post that I used for my information, you can actually see in there where he's got that's what it's called. He's got this link to this video. It's very, very good explanation about TLS and whatnot. And then whatis.com, just to kind of get some more explanation about TLS and the layers and whatnot. So here are my actual URLs and whatnot. If you want to take a second to do pause the video, take a screenshot, whatever, to find those websites. There those are, and that is the end. So there we go.